Hey students, in this video I'm going to continue going over the notes of 3.1, absolute value notes of functions, but I wanted to first introduce you to what absolute value was, which I already did in the previous video. So now I'm going to talk about what the functions are going to look like and what your job is to do as a student. So here are the graphs you learned about in Algebra 1, the linear functions, quadratic functions, exponential functions, and that's all you learned in Algebra 1. But you learned all about analyzing them. You learned about finding the x-intercepts, the y-intercepts, the vertex for quadratics, the axis of symmetry for quadratics, and of course domain and range. So your job as an Algebra 2 student is to find all those attributes again. So these are called attributes for all the functions we're going to study this year. So starting with absolute value functions. Absolute value functions are going to look like a V-shaped graph. And just like quadratics, they're going to have a vertex and an axis of symmetry cutting through the middle. You pretty much can look at them like cousins of quadratics. They're pretty much similar. The only difference is that you have straight lines instead of curves. Please understand that the x-intercept are points, so you have to write them down as x comma 0, like whatever x value you have comma 0. And then the y-intercept is also a point, so just carefully write down the 0 in the right place. Y-intercepts have the 0 on the x and then comma y value. The axis of symmetry is an equation, so you need to also remember that it's an equation as x equals a number. That number tends to always be that x value that you have for the vertex, which is why in this example it says x equals h, because the vertex is h comma k. And this is written h comma k on purpose because the template for transformations, if you recall, was a, f, b, x minus h plus k. Because that h and k right here are that h and k on your transformations template. All right, so let's go over the parent function, which is this one right here on the corner. This is the equation for the parent function of x absolute value. So just like for linear, the parent function was y equals x, the quadratic had y equals x squared, and the exponential has y equals ab to the x power, I believe it was x squared. No, not x squared. Y equals 2 to the x. That was the parent function for exponential. So this is the parent function for absolute value. Let's analyze this real quick. Your job is to identify these 6 attributes from any function of absolute value. So the first one is vertex. Vertex is once again located at that turning point, just like in parabolas in quadratics. We have a vertex on the absolute value functions, which is right here in the parent function at 0, 0. So that will be your vertex. For the axis of symmetry, it is a vertical line that passes through the vertex. So in this case, it is on the y-axis, but we're not going to say just 0. We're going to have to say the equation of the line, which is x equals, and then the number. So it's x equals 0. X-intercept is, again, wherever it crosses the x-axis. In this case, it is touching at 0 once again, so 0, 0. But keep in mind that if we translate this graph anywhere else, like shifting it left, right, up, or down, those x-intercepts will change. The y-intercept is where is this graph touching on the y-axis. So this graph right now is currently touching at 0 as well. But once again, if we shift it somewhere else, that will change. All right, the last two for domain, as we've talked in class, domain is going to still be left to right. Range is going to be up and down. But in interval notation, we're looking at writing down a minimum value, comma, maximum value. So if you look at this graph from left to right, what is happening in this graph left to right? Well, according to this, you have arrows at the ends, which means you're going to have negative infinity going left, positive infinity going right. So your notation for domain will be negative infinity, comma, positive infinity. And then you have to decide whether you're going to put brackets or braces. Brackets means that we are stopping there and including, and parentheses means we are just stopping there or approaching that number technically, but not including that number. So as you know, infinity does not have an exact value, but it is an idea of where that value is. So that is you knowing we're going to always use parentheses for infinity signs because we're always approaching infinity, but we're never touching infinity. So for the range, we're going to go up and down, looking at this graph up and down. The minimum, always write the minimum first, followed by the maximum. And then we're going to have minimum meeting the lowest. The lowest that this graph goes is right here, which is a 0 on the y. And what's the highest? Well, it has arrows, so the highest will be infinity. So we're going to write 0, comma, infinity. And on the sides, we are going to say that we are approaching infinity with a parentheses. But on the left side, we are going to put a bracket because we are actually stopping at 0 and including the 0. So that takes care of the example of analyzing these 6 attributes for the parent function. So now we're just going to analyze them in any function of absolute value. I'm going to go over the left 2 examples, and please go ahead and try the 2 examples on the right. So in class, I asked a couple of students if you prefer for me to explain this by hand or calculator, but because this is a video, I'll explain both ways. So to calculate this and fill in the table and graph by hand, what you're going to do is pretty much look at the equation given to you, which is absolute value of x minus 3 minus 5. And you're going to just think of random numbers. Let's say we put a 0 in there. In the table, if I have 0 as the x, I'm going to put a 0 in there. So y equals absolute value of 0 minus 3, absolute value, and then minus 5. And again, this is just a random x value that I've thought of, just to see what happens. So then we clean this up, we simplify 0 minus 3, absolute value of 0 minus 3. 0 minus 3 is negative 3. The absolute value of negative 3 is just 3. So then now we have minus 5 after that. So 3 minus 5 is negative 2. So at x is 0, we have negative 2. So I'm going to plot that point. Okay, and we can keep doing this by hand, 1 point at a time. Or what we can do is use our resources, which is the calculator, and go to graph and type this in here. So absolute value, x minus 3, step out of the absolute value part, and then minus 5. Press enter, and I actually did a small mistake. If you look at my notation, it looks like I had a negative 5 instead of a minus 5 because there's a dot. So I need to delete that and type minus 5. There you go. That's the correct one. So be very careful typing your minuses and your negatives. So this is the correct one. It's touching at 0, negative 2. But to speed things up, I'm going to go straight into the table. So what I'm going to do is press Control and then the letter T. Control T, here's the table. Immediately I get 0, negative 2, 1, negative 3, 2, negative 4, 3, negative 5, 4, negative 4. So what I'm going to ask you just to do is, before you just write any random number here, I want you to ignore the x's and look at the y values. Look at the y values and notice that there's a pattern here. At 5, negative 5, above that is negative 4, and below that is negative 4. Above that is negative 3, and below that is negative 3. So if I go up, that's a negative 2, which means that if I go down, then that's a negative 2. So what this is telling me is that at negative 5, I have a turning point. That 3, negative 5, I'm going to write it down in the middle, and I'm going to also plot it here because that's my turning point. And then above that, I have 2, -4. So 2, -4. And below that, I have 4, -4. 4, -4. So as you can see, it already created that B. And then above that, I have 1, -3. So 1, -3. And then below that, I have 5, -3. All right, so what I was trying to show you is that by doing that, you create a V, and you can already tell what the other points are going to be at based on the ratio from one point to another. You could ignore one side and just look at the right side and look at it as a line. This is a rise over run ratio of rise 1, run 1, rise 1, run 1. So rise 1, run, and I can keep plotting more points. If I run out of space, I can look at the other side and notice that it's the same pattern. Rise 1, run 1. So I'm going to keep going. And this is how you can create a perfect V graphed by hand based on your calculator table. So this is the absolute value for this graph. And again, this is the first time you've ever seen it, but as far as shortcuts, if you're ready to learn some shortcuts, you could have written the template of transformations here. And you would have noticed that once again, your H and K are actually these numbers right here. So that means that your vertex is your HK. And if you can tell the vertex from there, because that's HK, that is your vertex, which is 3, -5. According to a table, according to the graph, that is your vertex right there. And also according to the equation. So therefore, if that's the vertex, your axis of symmetry is going to go right through that middle, through that vertex at 3. So you're just going to say that the axis of symmetry is x equals 3. Okay, so now we're going to identify the x-intercepts. X-axis is right here, x-intercept right there, x-intercept right there. So we need to write them down as points, -2, 0, and 8, 0. For the y-intercept, the y-axis is right here. So this is your y-axis, and we're going to write it as 0, -2. For the domain, you need to understand that you plotted this, but if you zoom out, there's more points. So there are arrows technically at the end of these lines. So if there's arrows, domain, we're going left and right, forever to the left. So that's -infinity. And forever to the right. So that's +infinity. And once again, if it's infinity, we're going to write parentheses on the sides. For the range, we are looking at it as up and down. So what is the highest and the lowest this graph is going? We're always going to start with the minimum first. So let's look at it this going down. What's the lowest that this graph goes? According to this, it's -5. So -5, comma. Highest will be forever up, so infinity. I put parentheses right away because it's a habit from writing a point. However, you need to switch that this -5 is actually a bracket because you are stopping at -5 and you are including -5 because there is a point there. As far as infinity, once again, infinity will always be parentheses. So that's the first example. Pause the video, rewind if needed. Let's try the next example. Here we have 1/2, -1/2. So I think it's just easier to graph it and then just fill in the table. So let's do that. To remove the table from the calculator, do Control-T again, and that takes it away. You can double click this and then delete everything and retype it. So we're going to type -1/2 absolute value x minus 1. plus 2. So here is that graph, and we can also find that turning point by analyzing the graph. So if you remember from Algebra 1, you can go to Menu, you can go to Analyze, and it's not going to say vertex, but it will say minimum or maximum. So you have to understand that if your graph looks like this, you're going to have a highest value, so that's a max. So what we can do is find the maximum, or what we can also do is go back and trace points. So if you do graph trace, it actually traces the 0, which 0 means x-intercept. It also traces the y-intercept. It traces the maximum value. And then it also traces the other 0, the other x-intercept. So I think tracing is your easiest bet here. So let's go ahead and write those points down. I'm going to start once again with the furthest left. So that was -3, 0. And then after that, by the way, if you type -2 like separately, press enter, it also gives you a point there, but that's tricky to type. To plot. So I'm going to try -1. So -1, 1 is a point. And I'm going to plot that. And then at 0, enter. So at 0 is 1.5. I'm going to try to plot that. 0, 1.5. +1. +1 is at 2. 1, 2. According to this, remember 1, 2, it is telling me it's maximum. So that means that 1, 2. So I'm going to write those points down. 1, 2. That is my maximum. That's your vertex. And then just grab another point that can help you plot it. So let's try 2, 3. At 3, 1 is another point. So I'm just going to write these. And by the way, with just these points, this is enough to tell you once again how to plot the other points. You can just focus on the vertex, and on the right side of the vertex, I went down 1, run 2. Down 1, run 2. Down 1, run 2. So this is how you can plot other points. And down 1, run 2, down 1, run 2. So that's the graph. So now let's quickly identify the 6 attributes. So vertex, once again, will be that turning point at 1, 2. Axis of symmetry will actually go through that to vertex. So you just have to identify what that x value is at. So it's 1, and we're going to write x equals 1. X-intercepts, we're looking at -3 and +5. So -3, 0, and +5, 0. For the y-intercepts, we're looking at, again, that little decimal that I had to plot. And if you're using your calculator, you can always go back there and it tells you it's 0, 1.5. All right, for domain and range, once again, these do have arrows at the end because they're going to keep going, which means the domain is -infinity, +infinity, with parentheses on the sides, minimum, maximum, approaching but never touching. Range, we're looking at it up and down, starting with the minimum. So what's the lowest that this graph is going? Because it's going down forever based on the arrows, we're going to have -infinity first, then the highest, the maximum. The maximum is a 2, 1, 2. So then now, because we are touching 2, we're going to put that bracket and then parentheses for infinity. So this is the analysis for the 6 attributes for this example. Okay, so go ahead and make sure you try the 2 examples on this paper right here. And if you have any questions, let me know.